Hi, this is Dr. Herndon, and this is part 2 of our review of medical calculations. In this video, I will be explaining and demonstrating how to calculate a drug dose and how to calculate an amount of a drug that we're going to administer to a patient. In order to be able to do these calculations, we need to know 3 things. We need to know the animal's body weight, the drug dosage rate, and the drug concentration. A word about the terms dose and dosage. These 2 terms are often used interchangeably. It's important to know the difference, and for our purposes, a dose of a drug is what we're going to be calculating. It's the quantity of drug active ingredient that's delivered to a patient at one particular time. So you'll often see a drug dose written as like 20 milligrams or 20 units. A dosage rate, however, this is something we don't have to calculate. A dosage rate is going to be given either in the veterinarian's orders, or it may be found on the drug label itself, or we can look it up in a drug formulary such as Plums. This is the amount of drug per unit of body weight, and you'll often see it expressed as mgs per kilogram. This is probably the most common way it's expressed. Sometimes you'll see it as mgs per pound, other times as units per kilogram. And again, this is not something that we have to calculate. Our dose is equal to the animal's body weight times the dosage rate of the drug, which is going to be a given. Now we can weigh our patient and get body weight. Sometimes we weigh in pounds, oftentimes we have to convert to kilograms, times the dosage rate. Again, the dosage rate is a given. It's either going to be given in the veterinarian's orders, we'll find it in Plums, or find it on the drug label occasionally. The thing to remember is that if you're working with a dosage rate, let's say in mgs per kg, your body weight needs to be in kilograms as well, so we could cancel out these units. We need to work with the same units. By the same token, if you're working with a drug dose in mgs per pound, you need to make sure that your weight is in pounds as well, so those will cancel out. All right, let's look at this next formula here. So we've calculated drug dose right there. If we want to know how much of a drug we're going to give a patient, let's say how many tablets or how many mils or how many ounces or something like that, we use our dose that we've just calculated, and then we have to find the drug concentration. Dose divided by drug concentration equals the amount that we're going to administer. So we can put it all into one formula here. The amount of drug that we're going to give to a patient is the body weight times the dosage rate, that's your dose formula, divided by the concentration of the drug. So you may be asking yourself, well, where do I find the concentration of the drug? Well, you need to go directly to the medication itself and look in the label. If you pick up this one on the left, this is propofol. This is an injectable anesthetic drug. You can see in big blue letters right on the front, it gives you the concentration in a percentage. We're going to talk about solutions later on. 1%, this is a 1% solution of propofol, but they've kindly given you the concentration in mgs per mil too on the label. You can see it down there, 10 mgs per mil. In the middle here, this is amoxicillin capsules. They show you a picture of the capsule in the front, and over here in this red circle is the concentration, 500 mg. So what this is telling you is that in each capsule there are 500 mg, so it's 500 mg capsule. Over on the right here, these are 2 different concentrations of the same drug. Midazolam, it's a benzodiazepine. These are injectable anesthetic drugs. You can see that they have different color caps. There's orange and there's green, and these signify that these are 2 different formulations of the same drug. This is important. So if you see 2 different color bottles, there's probably a reason for that. On the orange cap bottle on the left, you can see the concentration is 1 mg per mil, and the green top bottle on the right is a stronger one. This is 5 mg per mil. So you need to be careful when you're picking up something off the shelf that you're grabbing the correct concentration of drug. All right, let's look at these 2 drugs right here. These are going to be used in our next 2 examples that I'm going to talk about. On the left is Antirobe Aqua Drops. This is clindamycin hydrochloride liquid oral solution. It's an antibiotic. The concentration is right on the front of the box, and it's also in the front of the label. That's 25 mg per mil. Over on the right here, these amoxicillin tablets, Amoxitabs. If you look down on this blue bar down here, it says 100 mgs, and then there's a little picture of a tablet right down here. What this means is that there are 100 milligrams per tablet. Okay, let's try a dose calculation example. We're going to use our clindamycin over here on the right that I just showed you in the previous slide. We have all our information on the left. Our patient is a 10 kilogram dog. That's the weight. The orders given are for 10 mg per kg of clindamycin. This is the dosage rate. We know that the available drug we have, because it's sitting over here in my picture, is at a concentration of 25 mg per mil. The question asks first, what's the dog's dose in milligrams? And then second, how much or what amount of the drug are we going to give in mils? So we're going to set up our dose formula. Dose equals body weight times dosage rate. Our kilograms cancel out. Our answer is going to be in milligrams. 10 times 10 equals 100 milligram dose. So it's a 100 milligram dose. Now we have to get 100 milligrams from this 25 mg per mil solution. We're going to go to our second part. Amount equals dose over concentration. So the amount equals 100 mgs. We're going to use our dose here, divided by the concentration, which is 25 mgs per mil. Cancel mgs. 100 divided by 25 equals 4, and our units are in mils. So this patient is going to get 4 mils of the Antirobe Aqua Drops orally. Here's another example here. Using the amoxicillin tablets, we have a 40-pound dog. The order is for 5 mg per pound of amoxicillin, which this was a label dose. The drug is available at 100 mg per tablet, and it asks what's the dog's dose and how much drug will be given, how many tablets. Why don't you try this yourself? Pause the video, then when you come back, I'll go over it. Okay, I've written out our dose formula here. Dose equals weight times dosage rate. In this case, I didn't have to convert from pounds to kilograms because my dosage rate was in mgs per pound. That's important. We can cancel out our pound units. 40 times 5 equals 200, and our units is in milligrams. So here's our dose right here, 200 milligrams. Amount is dose, which is 200 milligrams, divided by the concentration of the drug, which is 100 mgs per tablet. Cancel our milligrams. 200 divided by 100 equals 2, and our units are in tablets, 2 tabs. So this animal will be getting 2 amoxicillin tablets for each dose. Sometimes drug dose rates use body surface area instead of weight. Oftentimes, chemotherapy drugs have dosage rates that are in mgs per meter squared instead of mgs per kilogram. Sometimes you'll see other drugs that use body weight in meters squared instead of kilograms as well. So meter squared refers to body surface area, and to be able to figure this out, what we need to do first is we determine the weight in kilograms of an animal, and then we go to a chart, a conversion chart, and look up the body surface area for that particular weight in kilograms. There's one in Plums that you can use. It's called Conversion Tables for Weight in Kilograms to Body Surface Area, and that can be found in the appendix. Let's try this example here. We have our patient, a 45-pound dog that's going to be treated for lymphosarcoma, which is a type of cancer, with a drug called vincristine sulfate down here, which is a chemotherapy drug. And they give you the concentration 1 mg per mil, which you can also find on the label. The dose or the dosage rate of this drug is 0.5 mg per meter squared. And this is an example where the terms are used differently. It says dose is 0.5 mg per meter squared, but you can see that this is a rate. This is your dosage rate here. So the first thing we need to do is convert 45 pounds to kilograms, and I have done that, and it comes out to 20 kilograms. Now from here, I'm going to go to the chart in Plums, and I'm going to look up 20 kilograms, and it will give you the body surface area, which in this case is 0.74 meters squared. So if we're going to go to our amount equals, instead of body weight, we're going to use body surface area. So that's 0.74 meters squared. Body weight or body surface area times dosage rate up here, which is 0.5 mgs per meter squared, divided by the concentration of the drug, 1 mgs per mil. We can cancel out body surface area. We can cancel out our milligrams. Our answer is going to be in mils, and I use my calculator to do this. And our answer is 0.37 mils of vincristine solution. It's important to note that when you're recording information in the patient's medical record, that you always record the drug dose of the active ingredient in the medical record, such as the number of milligrams of drug or units of drug, or it could be milli equivalents if it's an electrolyte or something like that. Don't just record the number of tablets or milliliters. If you simply write down that this animal got 20 mils of some drug, that gives you absolutely no information whatsoever whatsoever. Drugs come in many different concentrations. Here's an example here, Baytril. You can see there's 5 different types of tablets. 3 of them are these flavored tablets down here, which come in 3 different concentrations, 136, 68, and 22.7. And there's 2 types of capsules over here in 2 different concentrations. Then there's even an injectable form. So as you can see, if you simply wrote patient got 2 tablets of Baytril, we have absolutely no idea what the dose of the drug is that this patient received. All right, let's use this example here. This is a very simplified medical treatment chart. Over on the left column here, you have the date and time the medication was given. In the middle is the treatment itself, and over on the right are the initials of the person who gave the medication. So on the left over here, you're going to be writing the date that the medication was given and the particular time that it was given. In the middle here, you're going to write the treatment itself. So in this case, we're using the first example of the clindamycin. We'll be writing the dose amount of the drug, 100 milligrams, clindamycin, HCl, was given orally, so I'm writing PO, and then my initials, whoever did it. So this gives you the dose, the drug, and the form that it was given in at whatever time. Let's say it was 7:30 a.m. on the 10th of September. It would be incorrect to write in the treatment section 4 mils of clindamycin. This gives you no information as to how much active ingredient is in this drug. We know that we used a 25 mg per mil solution, but the next person reading this is going to have no idea what the concentration of the drug is. So this gives you no idea of how much that active ingredient that patient actually received. If you wrote it this way, 4 mils of a 25 mg per mil clindamycin solution, that would be okay, but then the person still has to go and figure out what the dose was. Okay, so this concludes part 2 of our review of medical calculations. Now go ahead and take the quiz that's on Canvas. It's called Calculations Quiz number 2.